Welcome to the software journey with GKey. Data warehousing concepts with real-time interview questions and answers. Lesson number 8. What are star schema, Snowflake schema and Galaxy schema in dimensional modeling?
In this part of training, we are going to discuss about dimensional modeling techniques. A dimensional modeling is used in data warehouses to design structures optimized for analytics, reporting and OLAP queries. There are three core schemas available in dimensional modeling. First one is star schema, second one is Snowflake schema and third one is Galaxy or fact constellation schema. First we'll discuss about what is a star schema. We have seen the glimpse of star schema in the previous video. Let us see this schema in detail. A star schema is the simplest and most commonly used dimension model where there is one central fact table. Surrounding it are dimension tables which are denormalized. The structure looks like a star here. Key characteristics are fast query performance. I'll show you why the fast performance. I'll show you with the diagram. It is for the fast query performance will be there for star schema. It is a simple design, best for BI dashboards and OLAP systems, and dimensions are denormalized fact tables. In this slide, based on this diagram, we'll discuss the things which we have discussed in the previous slide. Here it is a star schema diagram. There is a fact table which is directly connected to different dimension tables. Here, if you want to get the data from one fact table and a dimension table, there would be only one join required. The same way for this dimension and fact, only one join. For this dimension and fact, one join. For this dimension and fact, only one join required to get the data from these two tables. In such a way, these are denormalized. Normalized means the data is going to be divided into different formats. For example, if you take a product category, subcategory something, you'll be having different dimension tables and there would be different joins. Here, the fact table like star schema is a denormalizer schema. Based on this less joins, there will be query performance. In this way, star schemas are designed in a data warehousing or a dimensional modeling. Here, each dimension table is directly connected to the fact table, where we have discussed what dimension table is having what fact table used to have in the previous classes. You can get into those classes and you can know about what type of data dimension table is going to have and what type of data fact table is going to have. This is a star schema model that is available in dimension modeling. This is one of the schema models. Here you'll have more performance and less joins. In this slide, we'll discuss about next schema in dimension modeling, that is Snowflake schema. In Snowflake schema, dimension tables are normalized into multiple related tables. Here, fact table in the center, dimension table broken into subdivisions. Structure looks like a snowflake. Characteristics of Snowflake schema are uses less storage, more complex joins, better data quality but slower queries. These are used when dimensions have hierarchies like category, subcategory and product. For example, if you have any product table, that will be subdivided into subcategory and there will be another table and subcategory is divided into a category. Like category is divided into subcategory, and subcategory will be having a detailed product details. In such a way, category table is going to subdivide into two tables. To get the data from fact table to product table, you have to get into subcategory, you have to get into category and then fact table. Here, 1, 2 and 3 joins are required to get the data from the fact table by using a product dimension table. In such a way, here more joins are involved and it is normalized. Why? Because instead of having all the data in the single table, the data is divided into category, subcategory and product. something like that. This is called a normalized structure. Here in this diagram, dim date is one of the dimension table, fact sales is the fact table, dim product is a product table, dim category and dim brand. These are the different tables which are based on the dim product. These are subdivided. In such a way we can like divide the category also subcategory, something like that. Here one dimension table is directly connected, dim product is directly connected to a fact table, and dim category is connected to another dimension, and from here it is connected to a fact table. There is no direct connection to fact and dimension in this type of a schema. This is called a Snowflake schema. Here some of the dimensions are normalized to get the detailed information. They are joined by using intermediate dimension table when they want to join with the fact table. I think you got some idea about the Snowflake schema here. Snowflake schema will be having less performance because of the more joins. That is the main point you have to remember for Snowflake schemas. Coming to the next slide, here we are going to discuss about the third type of schema in dimensional modeling, that is galaxy schema, or we can say it fact constellation schema. A galaxy schema, also known as fact constellation, contains multiple fact tables sharing common dimension tables, used when the business has related areas of analysis. Characteristics are like these are integrates multiple business processes, shared dimensions reduce redundancy, and high flexibility used in enterprise level data warehousing systems. For example, here dim date is one of the dimension table, date key and month is another dimension table. Here it is a fact sales and fact inventory. These are the two facts shares the same date key and month key from date dimension, and here is a dim product which is shared by fact sales, and dim store is shared with fact inventory. Here dim customer, again it is connected to dim product, then it will connect to the fact sales. Here dim customer also connects to dim store and it connects to fact inventory. That means sharing common dimension tables among different fact tables. There would be multiple fact tables. As we discussed, the star schema or Snowflake schema will be having a single fact table that will be connected to a different dimension tables, whereas in galaxy schema we'll be having multiple fact tables sharing common dimension tables. Here the dimension tables, this dim product and dim store, are shared among different fact tables. In this way, the galaxy schema is built for dimension modeling. This is one of the schemas available in dimension modeling techniques. And finally, if you coming to the last slide of this class is, here multiple fact tables, shared dimensions, looks like a constellation. This is for a galaxy schema. These are the things available for galaxy schema. There is a quick comparison table we can see. I mean, there are different features like design, dimension, something like that. We'll discuss one by one. Coming to the design for star schema, it is very simple. Snowflake's kind of complex, whereas galaxy is very complex. Coming to the dimension, star schema dimensions are denormalized. Snowflake, these are normalized, and here galaxy schema dimensions are shared dimensions. Fact tables, there would be only one fact table for star schema. Snowflake also one fact table, and for galaxy multiple fact tables available. Query first performance, for star schema will be having more performance, and compared to star, Snowflake is slower, and galaxy schema will maintain the medium performance. Coming to the storage point, star schema storage is more, Snowflake storage is less. Why? Because it is normalized, whereas galaxy schema, it depends on the fact and dimensional tables design. Usage is a final feature. For star schema, most OLAP systems, these are used. Snowflake schema, systems with hierarchies, and galaxy schema, usage is like enterprise data warehouse. I think you got some idea about different schemas available in dimension modeling, that is star schema, Snowflake schema, and galaxy schema. Thank you.
Follow us on YouTube, LinkedIn, Instagram, and Facebook. Don't forget to like, share, subscribe, and Press the bell icon to stay updated with our latest content. Join the GKey community and grow your IT profession with us.